All right, go ahead and turn that back in, or one person per group, turn into the back. Make sure your name's on there. It's just a quick warm-up so I can give you some feedback so that you can learn and grow and get a little bit better. While that's happening, first off, I would go ahead and recommend that you take all the materials I just gave you, the vocabulary for systems of equations and inequalities, 5.1, 5.2, go ahead and put it into your notebook in the correct order. That way when it comes time for the next notebook check, you're good to go. Alright? It should be, for the vocab, the systems of equations and inequalities should be the last part of the vocab. For the task sheets and homework, 5.1 and 5.2 should go in that order after the 4.6 taking sides. You should still have a self-assessment in there that we haven't turned in yet, 5.1 to 5.4, and then the other assessments should be in there in order as well. Right? So if you go ahead and keep things in order, stay organized, it makes your life way easier in the long run. Alright, while you're going ahead and putting that into your notebook in order, getting those things fixed, I want to go ahead and talk about the first few bullet points on the agenda. First things first, the appreciation side of things. I just want you all to know that I really have seen a difference in you as students this year, especially mathematically, as opposed to last year. Ms. Anderson and I actually, if you haven't realized, we collaborate on everything together. We talk regularly, trying to make sure that we teach kids to the best of their ability, or best of our ability, so that students can learn to the best of their ability. And we've both commented throughout the year that y'all have been significantly better students as a whole. Homework side of things, we can still work on a good bit, but our ability to think mathematically and our ability to talk mathematically has improved significantly. And I wanted to encourage you on that because I know that we are really far into the semester at this point and we can get exhausted. Even having had a week off with Thanksgiving, we can be tired and not want to continue, but I want to encourage you to continue fighting the good fight, to continue chasing after improvement, right? The growth mindset tells us that if we continue to learn from our mistakes, if we continue to try and making mistakes in that trying, then we're going to grow and get better at everything we do, right? So your critical thinking has improved drastically. I'm seeing huge gains. Keep working on it. Keep fighting for it. Last thing I want to say on that is finish the semester strong. Get your homework done. Make up your missing assignments, right? I've started putting missing assignments over here. If you're missing an assignment, it's a 0 in the grade book and it's killing your grade. We've got to get rid of those things. That's why I'm trying to give you notifications about this. I'll put the performance assessment, the algebra tricks, whatever it's called, up here so that you know if you need to make that up as well. And a big part of that is your grades do not just reflect your mastery of the content. In college and other things like that, your grade will literally just be on how well have you mastered this content. But in here, a lot of your work ethic goes into it, right? Homework matters. It's only 5 points a time, but 2/3 of the time it's just, hey, did you try the homework? Because I know that if you're trying the homework, you're going to improve your understanding. You're going to learn, you're going to grow. And you're also going to know what questions you need to ask so that you can improve the most. I need you trying your homework, right? It's just simple things like that, getting the assignments done, that will make a huge difference for your grade, but more importantly, it'll make a huge difference in your growth mathematically and your comfort in the classroom. Make sure you're learning from your mistakes, because at the end of the day, mistakes are opportunities to learn, and they're opportunities to grow, and hold on to that. So throw back to that growth mindset. But again, I do want you to understand, I am seeing a difference, even if you aren't seeing it. You have improved drastically overall from last year. Thanksgiving. Y'all have a good time?
Sure.
Enjoy not being in school?
Yep. Yes.
Did y'all enjoy not seeing me as much as I enjoyed not seeing y'all?
Yep.
You really want me to answer that?
Just kidding. I kind of missed y'all every now and then. I like teaching.
Wish I could say the same.
I like teaching y'all. Did anyone have any favorite, first off, did anyone do any travel at all?
Heck, no, I stayed at my house.
Not with COVID?
No.
Smart.
It's not that it was COVID, I just didn't want to do anything.
I was just home.
Don't talk to me. You have to get it okay
I
with
was
Mr.
just
Henry to
not-
do that.
I was. And my brother killed a 10-point and I didn't. I'm still kind of pressed.
Little salty.
Yep.
Yeah, you posted on Instagram.
Anyone have any favorite foods that they had at Thanksgiving?
No, all food.
Tamales? That
Yeah.
traditional Thanksgiving dish.
Sweet potato casserole.
Sweet potato casserole?
Yeah.
That's always a good time. My dad likes making that too.
Mac and cheese.
Mac and cheese.
Oh, yeah.
Literally, last class, I think there was only 1 or 2 students who didn't say mac and cheese was their favorite thing. I don't think I've ever had mac and cheese at Thanksgiving.
What?
What?
You're American, right?
That's just not one of the things my parents make for Thanksgiving. Like, we do stuffing out the wazoo, we do lots of mashed potatoes, we do cornbread casserole, green bean casserole, sweet potato casserole, turkey.
That's your problem. Replace the cornbread casserole and mac and cheese. That's obviously.
Oh, I agree with you there. My parents love cornbread casserole or corn casserole, whatever they call it. I'm not a huge fan. They like it, you know.
It's trash.
What about rolls?
If you're
Oh yeah, we had
American-
the Hawaiian
Sweet
Hawaii
rolls.
sweet rolls.
Yeah.
Good time. All right, but anyone have any other favorites other than mac and cheese?
You're obviously not
I had
American.
Cracker Barrel.
Cracker Barrel, is that what you said?
Mhm.
For Thanksgiving?
Was it? I couldn't get together with my family because my aunt's sick. So.
Gotcha. I'm so sorry.
Yeah.
Personally, my favorite, my go-to every Thanksgiving and Christmas, to the point where my mom doesn't even ask anymore, she just knows, pecan pie, man. Every time. I love pecan pie. It's the best thing ever invented. Yeah.
I mean,
I'm just happy
homemade,
thinking
yes.
about
If you
it.
buy it from the store, it's garbage.
Do what?
I said if it's homemade, yes, it's literally the best thing ever. But if you buy it from the store, it's so garbage.
So, fun fact, I used to think that, but Publix has a good pecan pie.
True that.
And there's a place near Montgomery called Priester's. And Priester's pecan pies are quite possibly the best pecan pies I've ever had. It's like the perfect mixture of pecans with the
It's like
the filling inside. It's just so good.
Is that
And there's a
bakery
place
or
called
something?
Pie Lab.
It's Priester's pecan orchard. I don't know. I don't know how to describe it. They have a whole bunch of different things.
I don't know.
But okay. Really quick note. Before Thanksgiving break, we started on test corrections. The mindset being that we learn from our mistakes to improve and get better for a retest. Quick notes on those. One, if you're going to do test corrections, then you do them on a separate sheet of paper. But here's a couple of notes as well. Some things I've been toying around with, and this is what I decided on. You have to submit your test corrections at least 2 days before you want to retest. If you continue to make the same mistakes that you did on the original test, is that going to help you on a retest? No. So I want to see your test corrections before you do a retest so that I can give you some final written feedback before you do a retest. And that way, when you do a retest, I ask for it 2 days ahead of time so I can give it back to you the next day and you have one more night of studying. But that way that you can learn from your mistakes and you can grow and get better. I want you to be successful. Now, instead of that, you could just come to one of the tutoring sessions and I'll sit down with you and go over your test corrections, but one of those two things have to happen. Afterwards, we can schedule a time during enrichment, tutoring times, or if absolutely nothing else, during class, and that's when you can do your retest. At this point in the game, the ball is in your court. The videos are on YouTube/Schoology. You can link them through Schoology. There's Khan Academy videos that you can watch. There's 5 tutoring sessions a week that you can come to. I want you to be successful, but I also need you to put in the work to earn the grades that you want. Let's finish out this semester strong. We've got 2 weeks of learning, 1 week of exams. That's it. Let's get to the point of earning what we want to earn. We're now going to look at our objectives and 5.2, too big or not too big, that is the question, before we look ahead at the end of class. Any questions before we get started?
Yeah, what's with the cats? Why is there always a cat? Why can't it be a dog?
That's a good question.
Dog.
We did live dogs last
I don't know.
Dogs are
week. We
like,
did dogs and
okay.
cats last week.
Well, it's
I
dogs
get
and
that,
cats
but
again,
yeah, so-
but they have pictures of cats here in the thing.
Screw the cats.
I think there's dogs later in the later lessons.
Well, I'm just saying.
Actually, yes, 5.3 has 2 dogs on there.
Well, I'm just saying, like, if you have to go hunting.
And those are 2 adorable dogs.
I'm just,
What is that?
yeah, no.
I don't know.
Where's like the
They're
actual
adorable.
dog, like the pit bull, or like you know, a Rottweiler, you know, German Shepherd, something, you know.
Hey, you know, I'm sorry that nothing's good enough for you. We'll just have to move on. It's okay. Before we get started learning today, though, we definitely want to pay attention to our objectives. If you don't know what the objectives are, it's hard to learn what you're supposed to learn. Desiree, can you get us started with this first objective?
I can identify the boundary lines for constraints of the scenario.
Okay, there's the objective. We want to be able to identify and interpret the boundary lines for the constraints of a scenario. But what does that mean? Are there any terms there that we need to clarify because we're not 100% sure what that means mathematically? No, we're all good to go. We know what every term up there means in a mathematical context.
Boundary line.
Ah, there we go. Thank you, Corel. Yeah, a boundary line, right? Now, we should be able to put it together a little bit using some context clues and things we know about math. What do you think we mean by a boundary line?
The max or min that you can go to reach the number that you're wishing at. I don't know a way to put that, but you get what I'm saying. I don't put
So,
it separate. We both
a boundary line is creating a maximum or a minimum. Now, I want you to notice, is this a single point though?
It could be multiple, a point of something you cannot go past. Like, if I said 1 and 2, it could be anything between 1 and 2.
Well, it's not just that. Look at the term again. Boundary lines.
For the constraints of a scenario.
If we're talking about a boundary line though,
Like a property line. You
A
can't
line
go
you
over
have to
it,
stop
otherwise
at.
you get shot.
a line that you have to stop at. Okay, you have to stop at a property line. But if we talk about a boundary line, if we're talking about a line, is that just one single value?
No,
No.
it could be any value in between. That's what I was saying. Like if you pick 1 and 2.
Well,
It's
hold
gonna
on,
be-
Peyton. That's not the same thing. You said a maximum or a minimum, right? So I could have a maximum, but if I have a maximum on a number line, then that's just where I stop. That's a single point. Yes, I could have less, but the maximum is a single point.
Okay, so anything between 1 and 2.
But that's not what we're looking at here. Because if it's a maximum or a minimum, the maximum or the minimum is a single point. Right? Now there are other values, sure, that are solutions that make the inequality true. But if you're talking about a maximum or a minimum, that's a single point that it's stopping at, right? But this is a boundary line. Is there only one value on that line?
No, there's probably like 10.
I mean, it's a line actually, so how many points are there on that line?
Infinity.
Infinitely many, right? And so we want to recognize and look for these ideas of how we're going to identify the boundary lines, how we're going to interpret them. And so this line is now the constraint, is now the maximum, now the minimum. And so that's going to create some interesting ideas. The second objective, Emery, can you read it out loud for us?
I can identify all values that satisfy the constraints of an inequality through a shaded half plane.
Okay, so if this line is the maximum, would I look above the line or below the line? Think about that. If this line is my maximum,
Below it.
I should be looking below it, right?
Yes, because the maximum is just the furthest up you can go.
Correct, good.
Or you can
And
have
that's-
a relative maximum, however, where you could go necessarily either
So
way.
that's more about functions, and that's a little bit different than here, so we'll come back to that idea later. But I want you to notice, when you're talking about from 1 to 2, Peyton, you're talking about this kind of idea. But when we look at below this line, notice I'm shading. What am I shading? Look at that objective.
I don't know, I guess you're just real Slim Shady.
Yep,
Come
good
on,
job.
that's supposed to be-
Look at the objective.
You're making a boundary
I have the boundary
For
line,
the constraint.
but I'm shading the...
constraints.
That's not what it says.
Scenario.
Half point.
Thank you, say it louder.
Half point.
Half plane.
Ah, got it.
Half plane.
See how it's half the plane that I'm shading?
Oh, that's not on there.
Yes, it is. It's very.
It's literally the last 3 words.
Oh, there's one person. Okay.
Nope, that we moved on to the second objective. Okay, so we want to notice this idea, and we're going to talk about this pretty heavily over the next few days, but I also want you to notice, and this is important, we're looking to satisfy the constraints of an inequality. What should that phrasing remind you of? Satisfying the constraints.
Finding the solution.
If we satisfy the constraints, that's what makes the inequality
True.
true, and those are the
Solution.
solutions. So we've done solutions with one variable inequalities, right? That's what Unit 4 was all about. Now in Unit 5, we're looking at solutions for a two variable inequality, right? To get that line, we had to have two variables, both an x and a.
So kind of like with the couple that wanted to start the dogs and cats thing.
That's what we're building off of today.
They had a boundary of this is how much space we have. We can go anything under it, but this is the max.
And that's exactly right. So remember 5.1 was all about having the space constraint of this is the most space we have for our cats and dogs. And then there was this startup cost of, hey, I only have this amount of money to get us started. Right? And that's actually exactly what we're about to build off right here. As Carlos is considering the amount of money available for purchasing cat pens and dog runs, see below, he realizes that his father's suggestion of boarding the same number of each, perhaps 12 cats and 12 dogs, is too big. And so, I'll leave that there for now. We actually looked at that, and I'm glad Peyton remembered this. We looked at space, and for each cat pen, it was taking 6 square feet of space. Does anyone remember what it was for the dog runs?
Dumb cats. 32.
24.
24. The 32 did come up somewhere else. We'll talk about that in a second.
That was for money.
Yeah, that's for the money,
Yeah,
right? It's here in the startup cost. What did I do with those numbers and the 12 cats and 12 dogs to figure out how much total space they consumed?
Well, you could do a few things. You did. Well, first I did just dogs, so it'd be.
But hold on. We're looking at the idea of 12 cats and 12 dogs.
Okay, well then, I don't know.
What did we multiply?
What you have, what number you pick? What, 12 and 24, I guess, what you trying to say?
Okay, so it's 24 times 12 for the total space taken up by the
Dog.
dogs.
And then 6 times 12, and then add that up. Why do you know that off the top of your head?
This is the 4th class I've taught doing this.
Oh, yeah. Right.
And also I remember from doing it last time. Okay, so 360 square feet of space. And if you remember, they had exactly 360 square feet of space. So on the space side of things, 12 cats and dogs was fine, right? But if we're looking at the startup cost, how much does it cost for each cat?
32.
$32 for the pen, right? So how would I figure out how much money I'm spending on the cats?
32 times 12.
32 times 12. Each dog? $80 for that dog run. So how much total money for the dogs?
What, 8 times
8 times 12?
12? 80.
Okay. And so if I do those, that's 384 plus 960. I add those two together and I get $13.44. Does that satisfy their startup cost constraint? No, that is why Carlos was saying, hey, this doesn't work.
You okay?
Okay? So, we're going to pick back up with this idea, and I want you to pay attention to this. I also want you to know we're drawing very heavily off of which lesson? 5.1. Throughout today's entire lesson, I would have 5.1 out because you should have lots of points already there. And I'll show you why that matters in a second. So notice here in number 1, it says find at least what?
5 combinations of cats and dogs would be too big based on this startup constraint.
So 5 more combinations that would be
Too big.
too big, okay?
Or not too big.
After you find those 5 combinations that are too big, or as you find each one, what are you going to do at the end?
Go to sleep.
No.
Keep going.
What does it say right here? Plot.
Color.
Of these combinations that as a coordinate ground.
On a coordinate grid
I agree on that.
using...
The same color of each plot.
Okay. So we're going to graph each of these combinations as a point on a coordinate grid. Right? So I already gave you the graph sheet of paper. I'm going to give you some colored pencils in a second, but we want to recognize that we are looking at a coordinate grid here. What variables are going on this coordinate grid?
Cats and dogs.
Cats and dogs, right? Which one should go on the x-axis?
Both of them?
Can you put two different variables on one axis? No.
So cats.
So here's the thing. Typically, the x-axis is the independent variable. We're talking about cats and dogs. Does one of them have to be independent, the other dependent? No. So in this case, you can actually just choose one so that we're all looking at the same graph and so that we're all looking at the same equation at the end. We're going to let the cats be on the x-axis. Okay? So your x variable is always going to be cats. You also need to make sure that you go to at least 50 when you scale your x-axis. We good with that idea? Good? Okay? So if cats is on the x-axis, what's going to go on the y? Dogs. And then you need to go to at least 20 on the dogs. I'm just going ahead and giving you these because this will help make things easier for you later. Okay? That's not telling you which numbers you need to choose. You just need to scale the cats to at least 50, dogs to at least 20. Alright. Once you find your 5 combinations that are too big, you're going to find 5 combinations that are not too big, right? And then once you find the 5 that are not too big, you're going to plot those combinations as points using a... Did you notice how you went from that teal, blue, whatever it is, to this purple here? You're going to use a different color for these points that are not too big. Make sense?
So you put all on one grid?
Mm-hmm. Yep. And what I would do is, one, I would use 5.1 to identify some of those points, and I would just write the points down here, those combinations here.
For all 5?
Well, the 5 that are too big here,
Yeah.
the 5 that are not too big here,
Mm-hmm.
and then finally for number 3 you need what?
5 least combinations, cats and dogs, that would be just right.
So 5 just right here, and guess what you're going to do once you find the ones that are just right?
Plot these combinations as a point.
Thank you for reading instead of just guessing. Plot each of these combinations as points on the coordinate grid using another color. Okay? Now, one thing I want to establish that is very clear on this, if it is too big in respect to the $1,280, would it be greater than, less than, or equal to?
Greater than.
Greater than, right? Whatever you get from the cats and the dogs would be greater than your 1,280. If it's not too big, it's going to be
Less than.
So it's going to be based on money.
Also, it's only on the 1,280.
yeah, because remember that was their startup cost.
Oh, so it's not on the square feet?
Mm-mm.
Okay.
So remember, this is on startup cost. Notice how it's based on this startup cost constraint. We'll look at the space later. But if it's just right, we're going to be equal to 1,280. And I do want you to notice, there's a third variable here. And the way and we only have 2 axes, the way we're accounting for the third variable is by the colors. Right? Whether it is too big, not too big, or just right. We good with that? Any questions?
Trying to figure out how you put graph all these on one.
Well, it's just points, dude.
So each color is different color?
For instance,
Yeah.
and so you can't use this because it's already given. It says 5 more combinations, but you already know 12 cats and 12 dogs is too big, right?
Yes.
So this is my color for too big, so I go to 12 and 12, and I'm just making a point, but there's the point for too big.
Does it have to be that color, right?
No, I'm going to give you colors,
Oh, okay.
and it just has to be 3 different colors. What I would probably do is I would probably put this here or on the graph to indicate what the color coding would be.
So after you done, you should have 15 points?
Yes. You can have more, but you need at least 15. Does that make sense how I'm color coding those things too? So go ahead and get your 5.1 out, start talking with your group to see what points you want to use. You should have exactly the same points as each other. And I will get you the colored pencils while y'all are starting to look at 5.1 and talk through those ideas.
Nobody knows. But you can't be straight minded.
I'm sorry.